Hi everyone, welcome to the second video of Module 7, and here I'm going to give you a quick introduction about the deep learning. I'm going to tell you what is the deep learning, why should we use deep learning, and when should we use deep learning, and why do we consider the deep learning models as the black box model. So now that we have looked into two machine learning algorithms that are linear regression and the logistic regression, now it's the right time to go ahead and deal with the deep learning architectures. Because whatever we are going to do over here is very similar to what we have already covered in linear regression as well as the logistic regression. So understanding this kind of concepts are not going to be that difficult. That's my promise. And yes, also in one of our earlier videos, when we had just introduced you all to the machine learning, we had this kind of a discussion as in what is the difference between AI, ML, and DL. So I hope that you are having at least a basic idea of deep learning, that we know that over here also we are going to create some of the algorithms, but in a way that it's going to mimic our human brains. So that's what we are going to do in the deep learning part. And there are a lot of different type of architectures that we are going to deal with. And yeah, that's about deep learning that we are going to cover in this module. So over here, as we know, deep learning is basically a subset of machine learning. It's again some type of algorithm that we are having, but because it's trying to mimic how our brain works, it's slightly different as compared to all the different type of machine learning algorithms we have in the machine learning field. Because in machine learning, we don't just have linear regression and the logistic regression. We have a lot of different type of models which does not only follow this kind of rules. For example, all of these algorithms will come with its own beauty of mathematics. For example, if I talk about decision trees, it completely works in a different way. It does not have weights or biases like we have in linear regression and the logistic regression. However, we are going to carry forward the same kind of technique of linear and logistic and combine it together in a deep learning. And over here, you are going to understand a lot of these things in a better way. But yes, one thing you need to keep in mind, that deep learning follows this weights and bias idea throughout, and therefore we call it as a subset of a machine learning. Then we know that there will be a lot of combinations that we will be seeing, and therefore you will see that it's computationally advanced. And it's not that we cannot use machine learning for all the type of different problems. For sure, we can do it. But deep learning architectures are going to be much more efficient as we compare it to the machine learning algorithms. So whenever your data will be huge and complex at the same time, your go-to choice will always be the deep learning frameworks over the machine learning frameworks. Just keep that one thing in mind. If your data is huge and complex, go towards the deep learning frameworks. Now there is one more thing that is left to discuss about is with respect to the black box model. So what do we understand by this black box model? So whenever we'll be dealing with the neural networks, what's really going to happen is we already know that what is the design of this architecture and everything. But then how does all these kind of things come together and make sure that we are getting a very reliable result? We don't really understand that how it works. And therefore, we consider this to be a black box model. So yes, as compared to the linear regression and logistic regression over there, the things are straightforward, not that complex, very easy to understand how the things are working. And here is one example that you can consider in order to understand this black box model nature in a much more better way when we talk about neural networks. So what's really going to happen is that whenever you're going to train a particular model more than once, without doing any kind of changes in the model altogether, still you will see that after the training, the set of weights are giving you some different values as compared to what it was in the previous training. Yet it gives you the exact same result. Isn't it weird? Well, yes, that's the exact reason why we call neural networks as the black box model. We don't understand some of the things over there, and that's why it's the black box model. I hope this part is clear. And then here comes some different type of artificial neural networks that we have when we talk about deep learning frameworks. Out of which we are going to focus two of them in this particular program, which are namely the single and the multi-layer perceptrons, which we typically use when we see that the data is becoming very complex for our machine learning algorithms to handle. So we go ahead and apply this kind of tabular data with the help of multi-layer perceptrons, or at times even single layer perceptron. Most of the times you will see the applications of the MLPs when we talk about deep learning. Then along with that, we are also having the convolutional neural networks, and we typically use them when we are dealing with the image data or the video data. And then comes different type of architectures like RNN, that is recurrent neural networks, which we go ahead and use for the applications when we talk about natural language processing. When there is some kind of a sequence that we need to remember from the past, at that times sequence models are required, and RNN is one of them. Few of the other examples of the sequence model, you can take it as the LSTM or maybe GRU. All right. And along with that, we are also having transformers nowadays. I haven't mentioned it over here, but you must be aware about GPT, right? The chat GPT. So it's based on the transformers. Even this type of architectures exist in the field of deep learning. And then apart from that, we are also having this generative adversarial networks. And as the name suggests, it's basically useful to generate some kind of data out of it. So as a part of input, it takes some kind of data and then generates some kind of data on its own. So if I have to give you one example, let's say that you are dealing with some kind of black and white images of the galaxies. And if you want to colorize that image, or if you want to generate a colorful image from that black and white image, you can use GANs over there. And guess what? We are coming up with this kind of program very soon. Right after this particular program will be launched. And over there, it's dedicated towards this kind of GANs. It's going to be really amazing. But yes, along with that, as I mentioned, there are a lot more different type of artificial neural networks dedicated for some different type of purposes. But I hope that you are now clear about what are some of the basic different type of artificial neural networks available in the market. And the two of them that we are going to study about in this program is the SLP MLPs and also the convolution neural network.